Right, so in this video, let's analyze this equation a little bit. So what is this equation gives us? This is called the characteristic equation of simple harmonic motion. And on the left hand side, you have the acceleration. So acceleration is equal to a proportionally constant times the displacement. That means this tells us that the acceleration is always directed towards a fixed point, because when the now here in this case the acceleration is mentioned in the other way, right, towards away from zero. Sorry, zero means the O point, but it says that the acceleration is negative omega squared displacement. Displacement is measured from this point, right, towards the right side. So this quantity is a positive quantity, x is positive in this case, I mean. So omega square, omega is positive but it is multiplied by a negative sign. That means acceleration is a negative quantity when it is moving in this particular direction. So when it is moving in this direction, that actually it is decelerating, not accelerating. Now as we described the simple harmonic motion earlier, so this particle starts to move away from zero. When it is moving away from zero, or the O point, it is decelerating. So when it is decelerating, what happens to the velocity? Velocity decreases. When velocity decreases, and at a point it will come to rest. Then it will turn around and move forward towards the center. Then it will not stop here, because when it comes to this point, now it is coming with acceleration. That means the velocity increases. So at this point it will have a velocity, so it will not stop here, right? So it goes towards the other side, move away from zero. So when it starts move away from zero, then it starts moving with deceleration, because acceleration will change the direction when it just pass O. So that's what happens. Now, what is the maximum displacement it can take? Maximum displacement it can take, it is called the amplitude. Maximum displacement is called the amplitude. Amplitude is the maximum displacement of a particle moving with simple harmonic motion. Okay. Now, in this equation, we can check how the acceleration varies. Now you can see that since the maximum displacement it can take is a, so the maximum acceleration would be omega squared a. So let me just take the absolute value of this, maximum of the absolute value of the acceleration. So I'm not gonna consider about the direction for the moment. I'm just gonna find the maximum acceleration, right? Absolute value would be x replaced by a, you get omega squared a. This is the absolute value. So we disregard the negative sign here. So what is the minimum value? Minimum value would be when x is 0. When x is 0, your acceleration will be a minimum value. So this is 0. Okay. Now right. So what we have here is that now we can sketch a graph here with acceleration in the y-axis, acceleration in the y-axis, and in the x-axis you have x, the displacement. So what would be the graph? So x double dot equals minus omega squared y. So this sort of looks like y equal mx, a straight line that goes to the origin, but you can see that the gradient is negative in this case. So you will have a straight line like this, goes to the origin. Now this will not extend until infinity, so it will stop somewhere. So this part, this is the amplitude of the motion, a. So what is the maximum, what is the y value here? The acceleration is omega squared a. Now in this case the acceleration is minus omega squared Now this is the graph of the acceleration with respect to the displacement. Now let's look at an example now. Example. Suppose example. Suppose the displacement is given as a function of time x equal 10 sine omega t. So we want to find the acceleration, the maximum acceleration, maximum and minimum acceleration. So a minimum acceleration obviously occurs at zero at the center. By minimum I mean the absolute value of the acceleration. So how do you find the acceleration? You just differentiate it with respect to time twice. So you get x double dot minus omega squared 10 sine omega t x double dot is equal to minus omega squared x. So first we showed that the particle follows simple harmonic motion. Now what is the displacement? To find the maximum acceleration, the absolute value of maximum acceleration, you need to find the displacement. So let's take x equal 10 sine omega t. This is a sine function. You know that in sine function oscillates between 1 and minus 1. So what is the maximum and minimum values? So let me subject this one. X divided by 2 is equal to sine omega t. Now x divided by 10, let me get rid of this. Now x divided by 10 is equal to sine omega t. So you know that the sine value varies between 1 and minus 1. So x divided by 10 must vary between 1 and minus 1. Therefore, displacement varies between plus 10 and minus 10. This is the maximum value of displacement. This is the minimum value of displacement. Right. So, what is it? Amplitude? Amplitude is 10. Sure. Amplitude 10. Therefore, the maximum acceleration would be the absolute value would be omega squared 10. Okay.